Welcome to my session. We will talk about advanced data types and especially about JSON support. Thank you very much to everybody that actually picked my session for today. So I'm glad to present here. And this is, my camera isn't working well, so this is the only picture of myself that you will see here. So who am I? For many years, I was a developer and mostly programming in ASP.NET using C#. I was also using many other technologies. The first one was ASP, the vanilla, pretty old stuff. And WinForms, also Clarion, Oracle Forms, whatever, etc., etc. And I started to use SQL Server from version 2000. And through 15 years of my professional experience, I oriented myself mostly in SQL Server development and some optimizations. Last 8 years, I'm working for a great company named Span, and my current position is Senior Database Developer. For almost 2 years, I am leading the Croatian SQL Server user group meetings once per month. And 2019, with some friends, I organized the first SQL Saturday in Croatia. So we had also the second one a few weeks ago. And also I'm a co-founder of Data Weekender conference. I am writing my blog about SQL Server, and also this year, Microsoft rewarded me with the MVP status for my contribution to the community. I speak on various conferences and events, and you probably understand that I'm from Croatia, which is a small country in Europe. Thank you. So the agenda for today, we will first introduce a little bit about JSON and why is even SQL Server supporting JSON. Then we will see something about how to convert SQL data in JSON format, also how to read JSON data and import them to SQL, how to modify JSON data, and also some tips and tricks, maybe something useful about that. So what is JSON? JSON is, of course, JavaScript Object Notation. This is a language-independent, open standard format for data exchange between applications and services. You can store data in JSON format, and JSON format is simple and very popular. It is commonly used, for example, in AJAX applications, web services, REST, for example, NoSQL databases, etc., etc. In simple words, JSON objects are human-readable lists of key value pairs. And on the right side of the screen, you can see an example of a JSON document. It's mostly easy readable. So JSON actually supports only 3 basic data types. There are strings, numbers, and Boolean values, plus, of course, the null for representing null values. All other data types should be casted in one of these. As you can see, there is no, for example, date data type or date time. Dates are represented and processed as strings, of course. A JSON string is a sequence of Unicode characters surrounded by double quotation marks, and special characters must be escaped. Here you can see the escaping rules for special characters. Of course, control characters are always represented by the backslash plus U and the code of the character. So let's basically compare JSON and XML. So here is the representation of a customer record, both in JSON and XML format. At the bottom, you can also see the result from SSMS of the same record. So it's pretty similar, but not exactly the same. Second part of this, compared to JSON, to XML, JSON format is less verbose and easier to read. JSON objects usually contain less data than an XML object, and it's more adequate for network transfers, meaning less data, meaning faster transfer. JSON format contains less text than XML format. Data in JSON format are represented by arrays and objects, while XML is a tree structure. XML can store more complex data types, and it's more robust than JSON. XML can store additional information, and JSON can store only data. You have also some problems, because, for example, in XML, there is a native XML data type in SQL, and JSON data can be only stored in nvarchar max data type. So you have also an indexing problem, because maybe it will not be so efficient to search something in JSON. But at the end of the presentation, in the tips and tricks part, we will see what we can do to do something faster than that. And XML data type also is consuming less space in the database than nvarchar max. So you could, for example, compress JSON data, but of course, when decompressing, you have also performance problems about that. So the main question about all this story is, why would we support and use JSON in SQL? Of course, what the heck? But like XML, JSON is a standard and it should be supported, of course. Other vendors support it already, like Oracle, PostgreSQL, and many others. And some of them, such as PostgreSQL, are very serious and robust. And many different frameworks in these days use JSON, web services, applications, etc. So SQL Server from 2016 supported JSON for that. Okay, let's see how can we convert SQL data to JSON. So it's pretty much like creating XML data in SQL Server. You have the using for XML clause, and in SQL Server, we can use for JSON clause in the select statement. There are two modes supported by the for JSON clause. First one is for JSON auto. The JSON output will be formatted automatically. And the second one is for JSON path. The JSON output will be formatted by the query itself using aliases. And its purpose is to create more complex output like nested objects. You have three additional options. First one is include null values, because normally null values are not mapped to JSON property. So the whole item is missing. We will see some demos after. The second one is root. Similar to the for XML root option, you can use root option to add a single top-level element to JSON output. And the third one is without array wrapper. Using the without array wrapper option, we can format the result as a single object. We will show this in the example soon. Because of limited data types used in JSON format, SQL Server will convert data types by using the rules visible in this table. Data types not supported by JSON in SQL Server are geography, geometry, and some CLR-based user-defined data types. Of course, when you convert JSON to SQL, you must cast the data. And let's jump at the demo. Hopefully this is readable. Okay.
Can I just ask a quick question? When you said you need to convert the data, you noted that binary values are base 64 encoded. Does that mean that it generates base 64 encoded values, or you have to cast it as a base 64?
I mean, actually, that when you convert JSON to a SQL, you must case the data, because
right. Okay. Thank you.
Okay. Maybe I didn't tell this way, but okay. Sorry. Thanks for asking. Okay. So let's start to select the gin tonic acid ring for JSON auto firstly. And as you can see, of course, we have an error here. The error is for the reason because for JSON auto cannot work without a table. So for JSON auto requires a table always. Okay, let's use a database, one of the importers, and let's select something from a table. And oops, we have another problem. The problem is that sales customers contain geography data, and as said before, geography data are not supported. So actually, in this case, you should do something else. Okay, let's try if maybe XML is better. No, of course it isn't. So you have the same problem with XML for XML auto. Okay, let's finally only select few columns plus one current date, run it, and of course we have a problem also because you must always use an alias. So the get date cannot be casted because SQL Server don't know what is the name of this node. So you must always have a name of the column. And finally, one good example. So let's pass it here, form a document, and here you can see that we actually get a JSON array. These are elements, our customers, and here are the data. For example, the special characters are escaped by some rules. Okay, let's return to here. Okay, this is of course, the tabular representation of the same records, just to see the data. And as you maybe remember, I was telling you that JSON documents consume less data than XML. So let's check this. So we have here 1,500 characters. And in XML, we have only 1,000. Oops, of course, I lied to you. Not exactly, but the problem is actually that this XML, it's not so nice to read, let's say it in this way. So I don't actually prefer it. So I would actually create XML with elements. And in this way, I will get an XML result that's actually more readable. But now, if we compare it to JSON, we will see that actually the document is larger. But okay, this is only one example. Of course, in practical usage, always XML is mostly larger than JSON because, for example, XML has closed, every node must be closed and open and whatever. And in JSON document, you have only the name of the node and the value actually. So, okay, let's return. Okay, this is only how the special characters are actually escaped. And you can see this \u and the code of the characters, and it's pretty messy, this one, to read, but of course JSON must escape all the special characters. Okay, so let's see for JSON path. Let's run the first example again without the table. And now you can see actually that the result is returned. So that's the difference between. So for JSON path actually does not require the table. Lots like before for JSON out. Okay, and what now we can do? Let's run this example again. First 5 customers. Let's import them here. And now you will see actually that we have a nested object contact. So we accomplished this by using aliases. So everything before the full stop is saying to the SQL engine actually that we want to create here a sub-object named contact, and after then the name of this property. So we have contact phone, contact fax, and this is the way to create more complex objects with JSON path and using aliases. Okay, what do you think will happen in this example? So I want to have contact phone number, contact fax number, and GSM, for example, but they are not connected in this example. And if we try to run this example, you will see that we will get an error message. The point is that sub-objects must be connected. So I can do this, of course, but the correct way to accomplish this task is that the data on the same sub-object must be connected. Okay, null values. Okay, this is not the greatest query of all time, but it will show us how null values are handled. So as you can see, customer ID number 2 doesn't have a website, so the whole node is ignored. So actually in the JSON output JSON document, you don't have the nodes with null values. So we can solve this by using the include null values option. And now let's see what happened. Now, of course, the website URL is always included, even if it is null. Okay, second options is the root node. So I want give me first 5 customers and add a root node named customers. Run it and show the result. So now we have a JSON object, we have a customer node, and after array, and now we have elements of this array. So this would be actually the way if you want to create really some complex JSON documents in this way. Okay. We have also the without array wrapper option. Let's see what's the result of this. So if you can remember, before we had the array always was an array of objects, and right now we have only one element, and actually this is not an array JSON. It's a single object, of course, because I was selecting only the customer with ID 1. Okay, and now I want actually to select 2 customers, also without array wrapper. and it's possible, of course, but also you must know that this isn't maybe the best JSON document, because you have actually here error. So these are two elements that actually are not part of one array. Okay, but now we want to solve this situation by using, okay, give me 2 customers without array wrapper and add a root element named customers. Pretty simple. Okay, let's run it, and ta-da, we have an error, of course. And the error says root option and without array wrapper option cannot be used together in for JSON. Remove one of them, of these options. So, okay, I really don't know what was the point of this. Why is this not possible? But it is so implemented, and I can really not do anything about that. So this is one of strange situations with that. Okay, do we maybe have some questions about for now?
There are no questions right now, so
okay,
everyone's watching.
Let's continue. Okay, second part. So we have JSON element, JSON object, sorry, or document, and we want to get data and insert into some tables in SQL Server. For that, we can use OPENJSON, and it is a row set function, meaning table value function, and it returns an object that can be used just like a normal table or view. Depending on the usage, it can return data in 2 possible ways. The first one is with default schema, and meaning when the schema is not specified, of course, and explicit schema, meaning that actually the user defined the schema and what columns are returned to the user. Okay, so first one, OPENJSON with default schema. When you don't specify a schema for returned result, the OPENJSON function returns a table with 3 columns. Always there are 3 columns: the key, the value, and the type. The key, this is the name of the JSON property or the index of a JSON element. The data type of the column is nvarchar 4000, and the column does not allow null values. Value, this is the value of the property or index defined by the key column. The data type of this column is nvarchar max, and nulls are of course allowed. And the type, this is the JSON data type of the value. The data type of the column is tinyInt. You can see in this table possible values for this column and appropriate descriptions. So let's jump on the demo about that. Okay, I will not show you that JSON is not working on older version of SQL Server, but let's see the first example. So we have a JSON document and nvarchar max. It's actually a text, and select star from OPENJSON and this variable. Okay, and what we have here, we have an error. JSON text is not properly formatted, unexpected character J at position 11. Okay, I don't believe you. So let's check it out. Okay, format document. Okay, seems all good except here something. So actually we have a missing quotation marks here after the name. And really this is pretty much true because this is the something like 12 character, and SQL Server was pretty much exact where the problem is. So it told us at position 11. Okay, now we've corrected this JSON document. And here, as you can see, we get the 3-column result, actually. You have the first one is key, value, and data type. And of course, it's not clear what data type is what. But okay, this is probably string, this is probably number. Okay, the 0 is null, and this one should be Boolean, etc. So I actually want to create a small help function to return me the what data type is this. So now it's more readable, as you can see. So the first one, sorry. First one is string, 2 is int, null, true, false, array, and object. So we can see that this is the array because of the with some elements like name, gin tonic, drink, occasionally, whatever, and the parents are an object about with 2 elements. Okay, let's return to this example. So now, if you want to select only one node, for example, the parent node here, we can use, okay, select star from get JSON, from OpenJSON, the variable with our JSON document, and we can specify the subpath of the result we want to get. Okay, let's run this example. And as you can see, we only get 2 elements that actually are my parents. And the result is the same, 3 columns plus the 1 column with my help function. Okay, let's see what will happen if we want to select a non-existing friends node. Okay, we will get nothing because the friends node does not exist actually. And we will not get an error, but we will get an empty result set. Okay, but there is also a nice comment called strict. So actually, now we are telling to SQL Server that we want to read JSON, we want to read the friends node, but we are strictly to that. So we insist on that. And if we try to run that, we will get an exception. So when strict is specified, so you can only select the existing nodes. Okay, let's select the favorite drinks node. As you can remember, these are objects. So this is an array of objects, and of course, you should again read this in subselect or something. We will show examples of that also. What if we have some spaces in the key part? This is of course normal because JSON is really flexible. So actually you can have a name of the node with spaces containing. And of course, this is by quotation marks surrounded. Okay, so let's read only favorite drinks. Of course, I made a mistake here and SQL Server raised me an error for that. So if you want actually to read properties with spaces in the name, you must also surround the name of the node with quotation marks, like in this example here. Okay, let's return to the demo, but only short to the presentation, sorry. So OpenJSON with explicit schema. It's something similar like reading XML data in SQL Server. We can specify our own schema when reading JSON data. In this case, the function will also return a table, but the output columns and their data types can be specified by the user. The schema for the JSON data can be specified using the optional with keyword at the end of the OpenJSON function. So of course, this with is optional. Okay, and let's return to the demo. Oops, sorry. So how is this working? We have a JSON document. We are selecting star from OpenJSON, but now we have this with part. And of course, we are telling to the engine the properties. The first one is name. It is an varchar, for example, and the path is .name. So meaning we will get John Doe. Blog URL, for example, is on the node called blog URL. There, let's run it. And of course, we will get a nice table, not anymore with 3 columns, but now we can get as many columns we want to get and as many we specify actually. So this is pretty much better approach if you want to parse and put JSON data in your database. Okay, let's run the second example. Okay, what happened here? As you can see, for example, the favorite drinks, parents, and spouse are null. And actually, the spouse is okay to be null, but favorite drinks, we actually have a list of them. But why they are returned as null? The thing is that we specified actually that favorite drinks is varchar max, but SQL engine understand actually that favorite drinks is an array, meaning that actually this is a complex JSON object, and he don't want to parse this value into varchar max, and so he returns null. As maybe you can, we can return to the example before. Here, this was returned because we put at the end as JSON. So this is the correct way to read complex elements. Okay. Okay. What now? We have another error. JSON option can be specified only for column of varchar max. So I actually wanted to get the favorite drinks node, but I forgot actually that JSON document can be stored and processed only from varchar max. So this is the reason of this error. So we must know actually when using this JSON, we must always use the varchar max data type, and this is required. Okay, now let's see what we can do with the nested hierarchy. Of course, we can do the cross apply. We can use the cross apply operator. So let's get favorite drinks node varchar max as JSON, and then cross apply the favorite drinks node and extract name and drink that are varchar data type. And now in the result set, you can actually see that now we get, because cross apply is something like inner join, we get many records same, but the favorite drinks node are expanded and we can see all the values here. Okay. We'll skip this and let's jump to the presentation back. Okay, next we have two functions also. The first one is JSON value. This is one of the two functions with the purpose to extract values from JSON text. The second one is JSON query. JSON value is used to extract a primitive data type. So null, string, number, or Boolean. Only one important limitation of JSON value function in SQL Server 2016 is that a variable as a second argument JSON path is not allowed. So actually you cannot use a variable to specify the path. And from SQL Server 2017, this limitation doesn't exist anymore. So SQL Server 2017 supports variable for the second argument. If the extracted value is longer than 4,000 characters, the function return null or exception, depending. So in lax mode, it will return a null, and in strict mode will return an error. So remember the strict before. Okay, we will show the example. And second thing, JSON query. JSON query is used to extract JSON fragment or to get a complex value type. So only arrays or objects can be extracted with JSON query. The function returns a JSON fragment of type n varchar 4000. The collation of the returned value is the same as the collation of the input expression. And of course, if the value is not an object or array, what will happen? In lax mode, it will be returned null, and in strict mode, it will be returned as an error. Okay, let's see. So we have this JSON document. Of course, we are using it already the whole session. And we are using select JSON value from JSON document and give me the name, the block URL, the suppose, the burn of the Woodstock, whatever. And if we run it, we will get the values, of course, for this. Okay, and this is all readable. Of course, non-existing node cannot be returned because it doesn't exist, and it's null. And the suppose is, of course, null, so it's returned as null. Okay. But if you, for example, are using strict here for the non-existing node, we get an error because, of course, we tell to the SQL engine, you must return the non-existing node. So if this node does not exist, the document is not valid, and we get an error, of course. Okay, larger than 4,000 characters, we will get null. So this is actually 4,096 characters. And this is relaxed mode, so we actually get null. But as I told you before, in the strict, so strict, we will get an exception, of course. Hope this is okay. And the second one, the JSON query, is only to extract complex data types. So you will see that actually name and born after Woodstock are actually returned as null, because with JSON query, you can only return favorite colors, because favorite color is a complex data type. So you must actually know your data and decide when you will use JSON value or when to use JSON query, depending, of course, if you have complex or not complex values. Okay, let's use the strict, of course. And we will get an error, of course, because something is wrong with this document. So the problem becomes here, because we want to select name, and name is not complex data type, of course. Okay, so for now we are finished with reading JSON data to SQL. Are there maybe some questions, or I can continue?
No questions?
Great. I like when everything is clear.
Oh, super clear. I was just thinking, if there's a relaxed mode, I think the opposite should be tense mode or suspense mode or something like that.
Okay. Modifying JSON data. So to modify JSON data, you must use JSON modify. It allows you to update the value of an existing property, to add a new element to an existing array, to insert a new property and its value, to delete a property based on the combination of modes and provided values. So actually, if you want multiple changes, you must, of course, call it many times. It's clear. So you all remember replace, 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 or maybe the L-trim, R-trim in SQL. So JSON modify, it's something like that. So if you want to make multiple changes, you must call it multiple times. Demo. Okay. So I have a JSON document, I have name and the blog of URL block, okay? And I want to add the value currently presenting and example. So I'm using JSON modify, I'm using the JSON document. Here is the name of the node I want to do something with this, and this is actually the new value. Okay, let's run it. And we will get, okay, currently presenting, but it's 1. Notice that my intention actually was to get the bool value, like true, I'm currently presenting yes. But SQL Server don't know what I want, of course. I want gin tonic right now. And he actually saw this value of 1, and he decided actually that this is a number, okay, number 1. And if I want, of course, to get the Boolean value, like in this example here, I must, of course, cast the data to bool before. So SQL Server don't know what are my intention. So if you want to get specific data type, you must cast it to it, the value. Okay, what will happen if I want to use the strict option? Remember the nice strict. In this example, you will get an error. So actually, this command would be possible only if the currently presenting node already exists. So in this way, we could change the, for example, true to false or to whatever, but you cannot add a new element using the strict command. You will get an error. Okay. So for example, I want to add a more complex object. Like, for example, this should be an array, of course, JSON array of meetups. Okay, so I have 2 meetups value here. Yes. And I'm inserting, okay, I want to insert meetups node, and this is the meetup list, of course. But notice here that these characters are escaped. So meaning to the SQL, this is actually a text. Let's be sure about that. Yes. So this is surrounded by double quotation marks, and all other characters are escaped. So meaning this is a string, this is not an array. Okay, how can we actually get an array of that? The way to accomplish this task is actually that you must tell to the engine this JSON query. So right now, meetup list is a JSON query. Okay, let's run it. And now there is something completely different. We have an array here. Okay, and we have two elements divided, and there are not anymore escaped. Let's see here one more time. Yes, this is an array, and this is the first element of the array and second element of the array. Nice. So if you want to get an array, you must use JSON query. Okay, how can we remove one node? Of course, we must specify the name of the node and put null, of course. So the result is like the starting document, but without the favorite drinks node. It's completely removed. Okay, I have two meetups, of course. I want to remove the first. Okay, 0 is first, of course. The 0 element from the list. And what happened here? Of course, it's not actually removed. There are still two elements here, but the first one is null. So it's a little bit confusing. And how I can actually remove completely, it's pretty stupid actually. So I must give the whole new definition for this node, and I must replace it. So using the whole new definition of meetup list, I can accomplish this task actually. Okay. Okay, but if I want, for example, to change the first meetup to something about blah, 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 I can do it in this way. I'm using meetups node, 0 like first element, and this is the new value. So we started from new SQL Server functions, and we finished with something about new SQL Server functions. Nice. Okay. And the second one. It's legit. So if we want to change the non-existing lectures, first element of lectures, to something about new SQL Server functions, the resulting JSON document is pretty much the same like the starting one. So we don't have, of course, error here. But what will actually happen if we want to append a new element? So of course we must tell, okay, SQL, let's append it. So in this way, we'll get the third value, something about new SQL functions. And we started only with 2 elements, and now in the result we have 3. So to accomplish this task, you must use the append nicely. Okay, but what if we want to append something to non-existing lectures mode? Let's test it, of course, because testing is the best way to find it out. Oh, I'm so surprised. So actually, SQL Server was intelligent to add a new lectures node and to append, to give the value. Okay, only for this. Okay, but let's append something to the non-existing lectures mode, but using the strict command. And we get an exception, of course. So don't use strict. Okay, sometimes there are good examples for using strict, but usually you can get just problems with that. Okay. Okay, now we want to remove the favorite drinks like before with null value, of course, but what will happen if we are using strict? Let's find it out. So actually, the whole node wasn't removed, but only his value was removed. So you must use the strict if you want actually to have in the result the node, but only to remove its value. And it can be very useful in some situation. This. Okay, this is the pain of like this. So I want to make two changes in this document. I want to add a new meetups, and I want to delete favorite drinks node. Of course, I must call JSON modify 2 times, and what I want. And this, in this situation, you can have a really lot of code to accomplish this, but this is the only way. So you, of course, remember this: replace, replace, replace. Of course, if you want to replace 5 characters, you must 5 times call replace. And this is pretty much same like this. Okay, that's about modifying JSON data. Let's return to the presentation. What we have next is JSON or not to JSON. So is JSON is a function, of course, and it checks if the input string is a valid JSON data. It returns an int value with 3 states. Yes for it's 1, 0 for no, or null for null. Each JSON does not check the uniqueness of keys at the same level. So actually, if you look at this example on the right side of the screen, this is interpreted like a valid JSON document, but bad luck. Okay, and some tips and tricks. So we can import JSON from a file. Nice. For example, if you get a really big dump of some data in one JSON file and you want to make a one-time import in SQL or maybe 1 weekend import or something, you can, of course, import JSON from a file. The second thing, you know that indexing is not so well supported in JSON data, and we will show what we can do about this. And for example, XML is much better because in XML there is a natively supported indexing. And we will show some handy examples, something like compared to table row using JSON, processing data from a comma-separated list of values, hashing some results, and blah, blah, blah. So let's try this. Demo, of course. Okay, is null. Let's see the is null function. So pretty much what I told. Null is null. This is, of course, not a JSON document, so it's returned like 0. And this one is a nice formatted JSON document, so it's returned like 1, like true. Yes. Okay, is this valid? I'm not really sure. Maybe JSON is not my favorite also, let's say, language or something. But this is actually pretty much a dilemma. So SQL Server is sure that this is a valid JSON document. Maybe somebody that is watching this session know better than me if this is really a good example or not. But SQL Server cannot tell us that actually he doesn't check for repeat node names. Let's jump in Visual Studio Code, and of course this is something duplicate object key JSON blah blah blah. So I would say this is not a valid JSON document. Okay, so imagine actually that we want to create a table for some user settings in JSON. And of course, we have some key of this test user settings table, and we have app settings that actually we want to be sure actually that the input will be JSON. So we can of course create a check constraint. So check if is JSON is 1. Okay, let's create this table. Table created. Let's try first insert null. Okay, this is okay because I told to the system null values are supported. So okay, insert the second value. Oops, there are problems. Why? Because this is not valid JSON document. And I, of course, created a check constraint forcing the system that actually the input for that column must be a valid JSON document. And the third one, insert, is a valid JSON document. So I actually get only 2 rows, the null one and the one with JSON settings. Okay, let's drop it. Okay, here on my hard drive, I have a big JSON file, 500 megabytes. And of course, I want to read it. So I can do it with open offset, bulk import, blah, blah, blah. So this is just the basic import with OpenJSON. I read it, the free values. Of course, I could specify the column names and blah, blah, blah. But this is only the example that actually you can read directly the file with JSON file. Okay, let's talk about indexing. So I want actually to create a test table, and I want to insert some JSON values. I want to turn on statistics. Okay, you can see, so this is a new table. We have here customer IDs, and we have the representation of these customers in JSON format. And I want actually to get any customer that is from Idaho City. So let's select it. Then we have 75 logical reads. Okay, it wasn't actually so slow because we don't have many records. But as you can see, this is the whole table scan. So actually, if we had here like, I don't know, 1 gigabyte of data, this query could last forever, maybe. So what I will do, I will actually add, alter the table. I will add a computed column, and I will tell to this column that actually it's extract JSON value from customer data that is actually postal city name. Nice. And I will also create an index on this column. So I added the computed column. I created an index. And now I want to repeat my select from before. Okay, but execution actually was somehow more intelligent, of course, but still isn't, of course, the best. But I could only maybe try to select from the JSON indexing where, okay, customer city, like, okay. The mainly problem is maybe also in the like, but
yeah, I think that's why you're getting the scan, because
yes,
exactly.
Of course. So
I
in
would be
this
super
way,
curious to see if you can search on the JSON value without the percentages.
oh, yes,
Wildcard.
this. Indexic, yes.
So it figured out that it's a computed column. That's pretty nice.
Yes, yes. It's intelligent, pretty much. Okay. Okay, let's drop the index. The second, of course, thing we can do is, of course, full text catalog. Okay, we are creating full text catalog, we are creating full text index, whatever. Of course, it will last some time before the catalog is built, whatever. But now we have only 2 logical reads. That's even better than before. And you have this clustered index seek. Maybe it's not still completed. Okay. Now it's better. We don't have exclamation marks. So full text match was used here. And this is also one way to improve the queries. And also the second thing you can actually accomplish is that actually you are not forced to search only for one column value, but this example will search for value Huiting in the whole document. So you will get actually 3 documents that somewhere in the text has Huiting. And this is also somehow an improvement. Okay, let's try. Okay, so you are a great guy, DBA. You have a nice table with 86 columns, like for example, sys databases, of course. And the boss can come to you and tell you, look, I want to get only the columns that are not identical. Oh, nice. What we can do by using JSON, it's piece of cake. So I will try, of course, to compare sys databases that actually has 86 columns, and I want to compare only different values. So only 9 columns out of 86 are different. So of course the name of the database, master and model, because 1 is master and 3 is model. Database ID is different, snapshot isolation state, etc., etc. So actually JSON is pretty cool for stuff like that. It's really fast. Okay, this is actually the same example. So I will not show it again. But I told you actually that you can process data from comma-separated list of values. So it's similar like split. Yes. So I get IDs divided by comma, and I want to get only the values of these IDs. So the only problem is actually that it's not so flexible. We must first fake that this is an array of type of JSON. And the second thing, if you have some errors here, like a missing element, you will of course get an exception. But it can be used, but it's not maybe the best approach to do this. Okay. Okay, this is only a theory about check constraint. So we could alter some table, add a constraint that actually the favorite color node is required. So this is the way, for example, to check if you get the correct values from some application into your database. So you can use this. You can specify many check constraints. So in the document, so for example, if somebody send you a JSON document with missing favorite colors node, you will get an exception and the data will not be inserted. So this is actually the way to force the user to send right type of documents. Okay, and the second example for which I like really to use JSON is, for example, to compare two tables. Because I often on my job I am syncing data between 2 or 3 systems, of course, and I want really to get a fast result. What records must be updated? So the way to accomplish this task is to, for example, get a hash value. So actually here you can see the hash value of the whole row. And if I have on 2 systems, on 2 tables, pretty much same records, but I'm not sure what records are changed, I create a hash record and store it in both tables. So next I can only compare these hash values and I can get the fast result what records are updated or changed. So this is pretty good. You can also use XML, of course, but JSON is smaller and I think faster because of that. Because of course hash byte, it returns var binary data type, and you can select the whole record, and for JSON auto, also in the way like, for example, for XML auto. But imagine you have 2 tables, and of course you can by ID pretty fast compare if the values are changed or not. So this is it about examples. And this is actually the end of my presentation. This is a pretty image we get to thank to all attendees and organizer and moderators, and thank you all, of course, to listen to my session. One. Yes?
There's an updated version of this image that thanks the speakers as well, because obviously you guys make the conference.
Oh, I didn't know. I saw only this and I take it.
Yeah. There was actually a question. There were 2 questions. So Chuck asked me to ask this at the end of your presentation. Is there a SQL tool or command to put subnodes or subarrays into a separate relational table, like a child table, or do I need to parse using these JSON query and JSON value commands and then insert? Did you get all that?
Yes, I understand the question. I really don't know if there are ready tools for that, but every time when I needed to do this stuff, I was doing it manually by writing queries.
Yeah, I mean, I guess the field must be open for someone to write an open source script and put it in a GitHub.
Yes, it could be
a general.
Yes, it could be really nice stuff, for example, but I really don't know if does it exist.
So Chuck, we're looking forward to you writing a dynamic SQL stored procedure and then making it public. Mike asks a question that I don't entirely understand what he means, but if you look in the Q&A tab, maybe you can understand what he's looking for.
How do you update for ID rows 1 and 3?
So he does select ID and test name for JSON auto. I don't think I understand, Mike, what you mean by that.
Okay, I will copy it. Okay. But you must, okay. Or the first way is to call
Mike
update.
says, how do you update some parts of the JSON array based on criteria? So he wants to do an update where on a JSON blob.
Wrong window. Oh, that.
Can I just say that comparing the two rows using the JSON without array thing was, I'm totally stealing that. That's absolutely beautiful.
Okay. Yeah, by the way, I will try to answer this question, but by the way, will you publish the script somewhere for this presentation or not?
Do you have like a repository or something? I could paste the link here in the chat and on the Slack channel. Otherwise, just show it on a slide or something.
No, I don't have nothing really ready right now, because I was thinking actually that maybe you will later get it. Okay, we will see that.
Yeah, just email it to us and we'll put it on the page when we publish. So I guess it's hello@groupby.org.
Okay. Okay, and the answer for this, I think, is not simple. So I actually don't know what to tell you, Mike. And
probably something like the, I mean, XML has some complex XPath type of syntax to do that, I think.
Yes, but
it looks like they basically implemented the same thing for JSON, right?
Yes, but I am not aware about this, because you have the JSON modifier and you must, okay, if actually this is an array, maybe we can change the array. Like, let me think. So this stuff. The second element of the array. I'm not sure. Let's try it.
Yeah.
Okay, okay, we have this test. But test name, no. But this is a table. Yes, this is a table. So actually, no, because we have 4 rows. If you want to modify the second one, it doesn't make sense actually. Why we can't? If I didn't,
yeah, I guess maybe
test where ID is 2 and set a new value.
Yeah, I think that defeats the purpose. I think what he was looking for was if you just have a standalone JSON blob. I would probably try, and you can try this yourself, Mike. I would probably try the angle bracket. You can use those to denominate like the first, the second, the third instance of something. I'm not sure if that works for JSON, but there's some pretty wild XPath syntax if you're working with XML. I would just try to translate that directly to JSON.
Yes. I don't know, actually, you can write me an email, Mike, if you like, and we can discuss this later or tomorrow, but out of the head, I'm not sure right now about this problem.
Cool. So thank you, Damir, for speaking. I got a few takeaways from this session, including the column by column comparison, which is a really neat trick. I'm definitely going to use that because you can automatically just unpivot an entire table in a single row. So thank you so much for speaking.
Thank you very much for having me. And if you will wait a few seconds, I will provide you right now OneDrive link to the materials. Is this okay?
Oh, perfect. Yeah, sure.
Just a second, I'm working on it. It will be fast. We have 10 minutes still, so it's not a problem.
Oh, I'm sorry, Chuck. I thought you meant the transcript. Yeah, the questions after will be in the video that goes up on YouTube.
Okay, let me find the chat. Chat. Where is chat? Chat is here.
It's yeah.
Here.
Awesome. Thank you. I will paste
here
that
are the
link
scripts.
into scripts for session. I put that in the Slack channel as well. And I'd say that concludes a very, very nice 2-day GroupBy conference. And again, thank you so much for choosing to speak for us. You're getting lots of thanks in the comments as well. Great. I wish you and all the attendees a great evening.